So Bob and his friend Joe are at the park. Bob knows he can throw a ball 30 degrees above the horizontal at 22.5 meters per second. There's a tree 10 meters off the ground, and they want to know if they hit the tree, and if they don't hit the tree, how far Joe would have to be to catch it. Bob's throwing point and Joe's catching point are the same, so we don't have to worry about height in this instance. We don't know the time right off the bat, so we can use velocity final squared equals velocity initial squared plus 2 acceleration, and then the change in y. At the top point, the velocity final is going to be 0, so you can set that there. And in a 30, 60, 90 triangle, we know that the hypotenuse is 22.5, and so the side opposite the 30 degrees is 11.25, or half of this. 11.25 squared goes here, plus 2, the acceleration. The acceleration is negative 10, or gravity, and then the change in y. 11.25 squared is roughly 126.6, and then we add negative 20 and the change in y. We can subtract this value over here and then divide, so you get 126.6 over 20 equals the change in y. So we know the change in y is now equal to roughly 6.33 meters. So it will not hit the tree. So now we want to find the range, and this is equal to 11.25 root 3 because of 30, 60, 90 triangle, which is roughly 19.48 meters per second. And we can find the time by doing 11.25 divided by 5, which is equal to 2.25 seconds. And we can find the total horizontal range by multiplying this time by the horizontal vector, since the horizontal vector will not change if there is no air resistance, which we are assuming. 19.48 times 2.25 gives us the final range, and that is equal to 43.83 meters. And so our final values are that the maximum height is roughly 6.33 meters, and so it will not hit the tree, and that the final range is 43.83 meters.